Hello everyone. Motion in 1D, motion in 2D. Na uniform motion, non-uniform motion ke dia hi syllabus azong azau sia chu. Okay, so let's see small topic na ga ve bang ve tin. Topic lin jong hello na topic nyau cha bo hin tin. Okay, so let's see a little bit of that in this video. Masapena chu motion in 1D to motion in 2D chu na ipipita 1D chu ball chai hoi tain masapena 1D chu piam tele motion in straight line. So in 1D, so what happens, the velocity and the acceleration of the object are always along the same straight line. Suppose suppose I can have a velocity along this side. Velocity direction chu ni be a point ha object chu hoi langa chi am na chi nelang chu velocity chu na selang chu. Okay, I can have a velocity like this and then acceleration also along like this. So this is positive acceleration na he ball weitan abana chu I can also have like this v hilanga ma a chu hilanga yum na negative acceleration ahilole deceleration jangkati ahilole retardation jangkati chu na abana chu two dimensions beham. So when the velocity and the acceleration, so these two vectors, they are not along the same direction na it is the same straight line la hilawale. So if there is some angle between them, suppose I can have a v along this side, I can have a along this side, so some angle between them. Then acceleration is a vector, has a velocity is a vector na ale two vectors ni chu iti pa le ke bang de ha. So if they have the same magnitude, magnitude I think direction on ke pa ngai chu na. So 1D means it should be in a straight line, so that means both of them have to point the same direction or exactly opposite direction. Okay, otherwise if they point if they have some angles between them, so it will form a plane. Okay, so that is motion in 2D na 2D so motion in a plane din so. Okay, so that is the basic difference. And the uniform motion chu ha. So uniform motion means constant velocity. Okay, so the velocity does not change with time. Okay, so does not change with time. Non-uniform motion, so when the velocity changes with time, so velocity depends on time. Okay, so that is non-uniform motion. Okay, so I'll give you some examples. V, suppose v is given as 2I cap. Okay, so here if you see v is, so you don't have any variables here na t zong umlo x y z abc mazam no chala number box 2 into I cap. Okay, so that means it is a constant na, so this is a constant, so that means this is a uniform motion. Okay, velocity does not change with time. I give you one more example. V equals to, suppose 2t I cap. Okay, so now you have t, so t is present here. So t equals to 1 achu v chu zat ha 2 I cap na, t equals to 2 achu v chu zat deham to 2 are 4 I cap, t equals to 3 achu v equals to 6 I cap. So you can see that as time increases, the velocity also increases. So the velocity changes with time. Okay, so this is an example of a non-uniform motion. Okay, non-uniform. Okay, so the first one is uniform. So uniform motion and non-uniform motion, right? Abale motion in 2D, 2 dimension to 1 dimension chu pidina. 1 dimension chu ka say was a straight line na. Suppose you have v equals to, suppose 2 I cap. Kutila direction hi velocity, direction is along x axis. I cap ke piche na, I cap ke piche, so that means it is along x axis. Okay, so that means this is a motion in 1 dimension, 1D. Na kutila 2D chu tabang ha. Suppose you are given v equals to, say 2t square I, right, plus say 3tz. So the velocity depends on time, right? So at t equals to 1, so what is v? So v is 2I cap plus 3z cap. Okay, so at t equals to 2, so what is v? So 2 are 4, 2 are 8 I cap plus 3 are 6 z cap. Okay, so now you can see that it is changing both on I as well as j. Okay, so it is changing on 2 dimensions. Now it is a non-uniform as well as a 2D. It is a motion on a plane. Okay, so this is a motion 2D as well as non-uniform. Okay, so non-uniform motion. So some examples. Nah, variable KP variable lang. So just like I have mentioned here. So uniform means the velocity remains the same, constant, does not change. Okay, non-uniform means it will change with time. About a 1D to become the straight line. Okay, so straight line motion is 1D. So 2D means it is a see something, some curve that you can draw on an XY plane. Okay, it is a plane, right? 2D is a plane. Okay, so 1 or 2 examples. Okay, so example, suppose you are given x is equals to, so 3t I plus z. Okay, so this is the position of particles, okay, with respect to time. Question to PM, so is this particle performing 1D, 2D, uniform, non-uniform? Okay, that is the question. It's a head adding also velocity head ngay na. So find out the velocity. So dx by dt. So that is how much? 3I cap plus 0. Okay. So if you look at the velocity, you have 3 into I. So 3 into I. So 3 is constant. Okay. I means along the x-axis. So that means this is a uniform motion and it is moving along the x-axis, right? So another example. So one more example. So x is equals to, so you're given 3t square, right? So plus 2z. So same question, is this 1D, 2D, uniform, non-uniform? So find out the velocity. So dx by dt. Okay, so 6t. Okay, here I have to add y cap. Okay, so I plus 2z. Right, so 60I plus 0. Okay, so now you see velocity is 6ti, so it depends on time. So that means it is a non-uniform motion. And then you have only I cap means x-axis, right? So that means this is a 1D plus it is non-uniform. So the previous question was 1D plus uniform. Okay, so x is equals to, so let's say so 3t I cap plus 2t z cap. Okay, so same question, particle is 1D, 2D, uniform, non-uniform. So find out velocity. So this is dx by dt. Okay, so if you differentiate this, you'll have 3I cap plus 2z cap. So question is whether this is a 1D or 2D, 1 dimension hum, 2 dimension hum. So now if you see that the velocity here is not changing with time, okay, it will always be 3I cap plus 2z cap. So that means the motion is a straight line, right? So if the velocity is not changing, so velocity means speed, magnitude plus direction, right? So if the velocity is not changing, that means the direction is also not changing. Okay, it is a straight line. So that means what is this? So this is a constant, right? So there are no t, it does not depends on, it does not change with time. So that means this is 1D as well as this is uniform. Okay, so last example. So x is equals to, so 3t cube I cap plus 2t square z cap. Okay, so this is x. So is it 1D, 2D, uniform, non-uniform? So you differentiate this one. So v will be 3 are 9t square I plus 2 are 4t into z. Okay, so now you can see that it depends on time. Now, so there is t on the 9t square plus 4t. So at t equals to 1, so you can see that v is how much? 9i plus 4z. Okay, at t equals to 2, you can see that v is how much? 2 are 4, 4, 9 are 36, I plus 2, 4 are 8. Okay, so you can see that the velocity is changing as well as you see the number in the I and the z. Chila I to z to magnitude pa hefilation. Chizong kikhel so na x lang azong kikhel, y lang azong kikhel. So that means the velocity is changing. Okay, so everything is changing. So this is the example of what? So 2D plus non-uniform. Okay, so this is an example to explain 1D, 2D, uniform, non-uniform. As I say, definition so 1D means a straight line. Okay, so velocity and acceleration are along the same straight line. and 2D means a plane. Okay, so there is some angle between velocity and acceleration. But as uniform to velocity is constant, it does not change with time. But a non-uniform to velocity changes with time. Okay, velocity depends on time. Okay, so here I will solve one NCERT question. Now, position of particles haokipiit question answer. X equals to so 3t I plus 2t square z plus 5k. Okay, so position of particle is given like this. So question to become, so find the velocity and acceleration of the particle. Okay, so question must happen to, so what will be the velocity and what will be the acceleration? Okay, let's just see. Velocity should become, so dx by dt. So differentiate the displacement. Na? Could let 3i cap plus 2 to our 4tz cap plus, if you differentiate 5k, you'll get 0. Okay, so 3i plus 4tz is the velocity. So meter per second. About the acceleration should become, so you differentiate the velocity. Right? So if you differentiate the velocity, you have 3i differentiation to 0. Not 3i is constant here. So you'll have 4t differentiation to 4z cap meter per second square. Okay, so velocity acceleration is like this. Okay, so next part of the question is find the magnitude and direction of velocity at t equals to 1 second. Okay, so at t equals to 1 second, so you have to find out the velocity. So we know that the velocity with as a function of time is 3i plus 4tz. Okay, meter per second. So at t equals to 1, so v at t equals to 1 is that the answer. So 3i plus 4 into 1 to 4 z meter per second. Okay, so this is a simple question. Nah? Okay, so now let's solve some questions, some competitive question. Okay, dong sa ho na. Here Japan he NEET 2023 question in. So question is what the position of particle is given by. So r is given as 4t square I minus 2t square z plus 5k. So where is t? So where t is in second and r is in meter. Find the magnitude and direction of velocity at t equals to 1 second. So you're given r. R should have 4. Okay, correction here. This should be 4t. Okay, 4ti, and this would be plus 2t square z cap plus 5k. Okay, you make a correction. So velocity is what? dx by dt or dr by dt. It's a 4i cap plus 2 to our 4 t into z cap 5k to differentiate as 0 na. So meter per second. Question should be the magnitude and direction of velocity at t equals to 1. Kutele, if you're given any vector, okay, so any position vector, suppose xi, yz, zk. Let's see magnitude hit in whole. So how to find the magnitude of this position vector? So you square the coefficients and add them. Okay, and then put them inside a square root. So this is how you find the magnitude of a position vector. So the same way you do here. So v magnitude is 4 squared plus 4 t equals to 1. So first you find out t equals to 1. So v at t equals to 1. So how much is this? 4i plus 4z meter per second. Okay, so the magnitude will be 4 square plus 4 square under root. So this is what? 4 root 2 meter per second. Okay, abanan chu piham. So abanan chu direction jong do chula na. So direction ki do ja chu. So you draw the vector. See here you have two components. In the velocity you have 4. This is the x component and then this is the y component. Nah? So see it is also changing. It is a non-uniform motion. Okay, and then you see it is a motion in 2D. Nah? So it is changing in the y-axis. So here you draw the graph. So if I draw the graph, so v at t equals to 0, at t equals to 1, at t equals to 1 I have velocity velocity 4i plus 4z. So that means it is 4, 4. So along the x it is 4 meter per second. Along the y it is 4 meter per second. Okay, so that means from the origin, if you draw this, so you'll get a triangle. Okay, or see, addition of vector bolo chula na, x langa 4 here, y langa 4 here, a resultant so langa see there. So the resultant will be along this side. Okay, so this is the resultant exactly in the middle. Now, let's say here, so let's say theta. So then this is 4, so this is 4. So they ask you direction. Direction is basically angles. Okay, angle. So that means what? Tan theta is equals to 4 by 4, right? So that is 1. So tan 45 is 1, right? So theta is how much? 45. Okay, so the answer is from 4 to 245. Okay, so next question, you have one question from Gmain. So here you're given the position of an end. So S is given as 2t square, so which is along the Z plus 5k. So question is find the magnitude and direction of velocity at t equals to 1. So they ask you velocity. So what is velocity? ds by dt. Okay, so 2 are 4t into z, right? So v is 4t into z. So you know that this is one dimension motion. Okay, it is a non-uniform motion because velocity depends on time. So 4t. So question is at t equals to 1. So v at t equals to 1. So how much is this? So you put t as 1. So you have 4z meter per second. Okay. So this is the so it is a 4 meter. Say the magnitude is what? So magnitude is 4 meter per second. And where is the direction? So z means plus y axis. Okay, plus y direction. So 4 meter per second along the y direction. Okay, so simple question. Nah? Another one here. So here you're given r is 5t squared I minus 5t z. Okay. So magnitude and direction of velocity at t equals to 2. So v is what? So dr by dt. Okay. So 2 are 10t I minus 5z. So similarly you see here, so velocity depends on time, so it is a non-uniform, right? And then you have two components, so it is changing on the two components, so that means motion in 2D, right? So 2 dimensions. Okay, so here at t equals to 2, so you have to find out the velocity. So you put 2 here, you have 20i minus 5z. Okay, so 20i minus 5z, they ask you magnitude. So what is the magnitude? So 20 square plus 5 square under root. 2 are 400 plus 5 are 25. So 425 under root. So how much is this? 5 into 8 are 45. So 5 into 5 into 5, 1 is 5, 5, 7, 35. So you'll have 5 square into 17. Okay, so that means what? 5 root 17 meter per second. So this is the magnitude. Okay, so that means option B and option D are wrong. So next is the direction. So where is the direction of this velocity? At t equals to 2. So here you can see that at t equals to 2, so the velocity is this one. So 20i minus 5z. Okay, so that means I have xy like this, xy. So 20 plus 20 is here. Okay, so let's say 20 comma 0, and then you have minus 5, 0 comma minus 5 is somewhere here, 0 comma minus. Okay, so somewhere here. So this is 0 comma minus 5 minus 5. Okay, so this is 20. So this is 20 comma minus 5. So here you see this triangle. Okay, you can use this triangle if you want. And so here you have along, okay, in the option you have only y-axis. Okay, they are asking you along the y-axis. So what you can do is you take the triangle like this. Okay, so A, B, and C. So here you have theta. Okay, you take out tan theta. So what is tan theta? So tan theta, so will be opposite divided by, so opposite divided by adjacent. So that means 20 divided by 5. Okay, that is 4. So theta will be tan inverse 4. So the angle is tan inverse 4, and it is along the, where is it going? It is along the negative, so it is along the negative y-axis. Okay, and the motion of the object, if you see, it is going like this. Okay, right, it is going along like this. So that means it is going downwards. Okay, if you look at the y-axis, with respect to the y-axis, the motion is going downwards. Okay, so negative y-axis and 5 root 17. So moving on, so now you have a motion in the plane when you have a constant acceleration. Okay, remember, ibola constant acceleration hi poi moham khavya kinematic last video na last topic motion in 1D so kinematic equation thumi bol chala na. So you have x equals to, see, ut plus half at square, and then you have v equals to u plus at. You have v square minus u square equals to twice as. See, when do you apply these three? So these three are applicable only when you have constant acceleration. Okay, otherwise you cannot apply it. So therefore, even in motion in a plane, if you have a constant acceleration, you can apply these three equations. Okay, but the difference is in motion in a plane so you have x-axis as well as y-axis. Okay, so there are two dimensions, 2D. So that is a plane. Okay, so in a motion in a plane, you have two dimensions, two axes, so x-axis and y-axis. So therefore, you can apply this equation so you can split them along the x-axis as well as y-axis. So what do I mean by that? Along x-axis, I can write as x equals to ux into t plus half into ax into t square. Okay, here ux is component of velocity along the x direction. Ax is component of acceleration along the x-axis. Okay, so similarly, vx is equals to ux plus ax into t. Similarly, vx square minus ux square equals to twice ax into x. Now, here along the x-axis, so similarly along the y-axis. Y-axis has equation to more energy. So y equals to uy into t plus half into ay into t square. Uy to become component of velocity along the y-axis. Now ay to become component of acceleration along the y-axis. So similarly, vy is equals to uy plus ay into t. So vy square minus uy square equals to twice ay into, let's say, y. Okay. Ux uy kiti suppose I give you velocity is given by 2i cap plus 3j cap. I cap to so this is your vx. Okay, so this is vx, and then so this is vy. Okay, so vx vy na two dimension to x to y ki split okay. So let's solve one question from NCERT. So you're given that a particle starts from the origin. Okay, it starts from the origin at t equals to 0. So it has a velocity of 5 I cap meter per second. So you're given that the particle has velocity 5 I cap meter per second, and then it moves in xy plane under the action of a force, so that produces a constant acceleration. Now acceleration ki pichu chala hai. So constant acceleration of 3 I cap plus 2 j cap meter per second square. Constant so you don't have any t here. Okay, so that means it is constant. It does not change with time. Okay, first question is, what is the y coordinate of the particle at the instant when its x coordinate is 84 meter? So when x is equals to 84 meter, so what is y? Okay, so that is the equation. Hotele azawa x component y component achom joma depend na. Then in constant acceleration, you know that r is equals to ut plus half at square. So without splitting x and y achum chuma zero as khal vai zia taina ji theso. So how do you write? So this is, so here you have x, so which is I cap plus y z, right? So this is equals to u, so which is along the, so ui cap plus uy z cap, okay? So into t plus half into, so ax I cap plus ay z cap into t square. Okay, so something like this. So from here we split it na, x equals to ux into t plus achum chuma ji na. Okay, so now here so here I can split, this is ax, okay, so this is ay, so here you're given only, so vx, so now vy is 0, okay, it means vy is 0. So if I apply this, write it separately, so I have x equals to ux na, like x to kpm 84 is equals to ux to 5 into t plus half into ax to 3 into t square. Okay, so here I get a quadratic equation, so 168 equals to 10t plus 3t squared. Okay, so or 3t squared, so plus 10t minus 168 equals to 0. You solve this, you'll get t equals to 6 seconds. Okay, so use quadratic formula and solve this one. So here you write along the y also, along the y, so I have y equals to uy into t, so uy to 0 na. Okay, so here this one is uy, okay, so this is ux, and this is not v, it is u, initial velocity. Okay, so here uy to 0 is a 0 into t plus half into ay to 2 into t squared. So y equals 2, so 2 gets cancelled out, so I have t squared, so which is nothing but 6 squared, so that is 36 meter. Okay, so what is the y coordinate of the particle at an instant? So x is 84, so that means y is 36. Okay, so here they can also ask you some more things. So what will be the speed of the particle at this instant? Now at t equals to 6. Suppose if you're given that one, so v equals to, so vx is equals to ux plus ax into t, right? So what is vx? So ux initial to 5 plus ax initial to 3 into 6, right? So how much is this? So 3 6 are 18, so I have 23 meter per second. Okay, so this is vx na. So similarly you can find out vy, so vy equals to uy plus ay into t, right? So how much is this? Uy initial is 0, ay to 2 into t to 6, so this is 12 meter per second. So that means after 6 seconds, so what is the velocity of the particle? So velocity of the particle will be vx I cap plus vy z cap, right? So how much is that? 23 I cap plus 12 z cap. So this is the velocity. Okay, let's solve one question based on that one. So here you're given an object has a velocity 2i plus 4z. Okay, it is a constant velocity, so at t equals to 0, that means initially it undergoes a constant acceleration of a equals to I minus 3z for 4 seconds. Time lang gapi jona lahi. So time is given, acceleration jong gapi intin, abana v jong gapi na. Question jon bido ham find the coordinate of the object, coordinates of the object if it is at the origin at t equals to 0. Na chila hi vile jona gapi ho hi. So here you're given this is how much? This is ux, right? So this is uy, okay? So this is ax, right? And then minus 3 is ay. Okay, so these are given. So you find out coordinates at tilson must have been x to piham ux into t plus half into ax into t squared. Ux to 2 into times is 4 plus half into a to 1 into time to 4 square. So 2 4 are 8 plus 4 4 are 16 by 2 to 8. So that means this is 16 meter. Now x. So similarly you find out y. Y equals to uy into t plus half into ay into t square. Uy initial to 4 times to 4 plus half into ay initial to minus 3 na. So here you see minus 3. So minus 3 into 4 square. So 4 4 are 16 minus so 16 by 2 to 8, 3 are 24. Okay, so how much is this? This is minus 8 meter. Okay, so therefore what are the coordinates? So option A answer is 16 comma minus 8. So this is the coordinate of the object at t equals to 4. But now the B part. Find the magnitude of velocity at the end of 4 seconds. Kutila magnitude holding also velocity head ngai so na. Kutila Vy to that Uy. Let's start with Vx. So Vx equals to Ux plus Ax into t. So Ux to 2, Ax to 1 times to 4. So that means 6 meter per second. So similarly Vy to that so Vy initial to Vy to Uy plus Ay into t. Kutile Uy to 4 plus minus 3 into 4. So that means how much? 4 minus 12. So that means minus 8 meter per second. Okay, so it is velocity, that is why you have minus. Kutile velocity formula sa pita. So Vx I cap, okay, plus Vy z cap na. Kutile so 6 I cap minus 8 z cap. So this is your velocity. Question chun iwa magnitude ado chula na. Magnitude ado le position vector kp phala chun magnitude tiki bolta. So 6 square plus 8 square under root. 6 6 are 36, 8 8 are 64. Root na so this is 100. So root 100 is 10. Okay. So after 4 seconds, the velocity becomes 10 meter per second. Okay. So that much. Nah, from the next video, motion in a plane projectile padio. Okay. So I hope you understand. We'll end up here. Thank you.